Greetings, Chem 1 students. This is the pre-lab video for It's Just a Phase, Heating and Cooling Curves. You can go ahead and read the introduction, some interesting information about Florida orange growers, but we're going to talk about the background information down here. Solids and liquids will differ in how ordered or rigid their structures are. And they also differ in the range of motions that the molecules or ions are allowed. Okay? Molecules are in different amounts of motion, less motion in a solid, more motion in a liquid. Molecules that are in a crystalline solid are packed together in a very ordered three-dimensional pattern called a crystal lattice. The motion of the molecules in this solid state is just limited to vibrations. We saw that on the notes when we were talking about phases earlier. Okay. The molecules that are in the liquid state are more free to move about and are not as locked in to a position as the solid state would be. A solid and its liquid are at equilibrium at the melting point, which is the temperature at which the crystalline solid becomes a liquid. So if we were talking about water, we know the melting point is 0 degrees Celsius. So what we would have there is we would have equilibrium between a solid and a liquid. The temperature is related to the average kinetic energy of the molecules, which is the energy of motion. As the temperature increases, the average kinetic energy increases, and the molecules begin to vibrate more rapidly. So as we are increasing temperature, we're increasing the kinetic energy, and we have greater amounts of movement. At the melting point, the vibrations become so rapid that the molecules begin to break loose. So right here we can see they're breaking loose from that fixed position, and melting will occur. The temperature of the solid-liquid mixture will remain constant at the melting point until all of the solute is melted. We've seen that with our phases and the diagrams we did. Think about quadrant number 2. That was the flat line. That was the melting point. We still have heat that is being added, okay? We still need the heat to be added. However, the temperature is not increasing. The temperature remains constant until the melting point, until all of the solid has melted into the liquid. That's something that a lot of people missed on the phase change gizmo, that at the melting point, the temperature remains constant. Okay? Although the temperature is constant, like I said, we still have heat that must be added to break those attractive forces of the molecules. The more orderly the packing arrangement of molecules in the solid state, the stronger those attractive forces are. So if we're in the solid state, the attractive forces between those molecules are stronger. Okay? They need heat to break the they need heat to break those and melt the solid. Just the opposite of when a liquid freezes. Energy in the form of heat is released to the surroundings. So we are releasing heat when we go from a liquid to a solid, when we are freezing. The same amount of heat is needed to melt the solid will be the same amount of heat that is needed to be lost to freeze the solid. So that is the melting / freezing point, depending on which way we're going, whether we're entering heat into the equation or we're removing heat into the equation. What you need to do is you need to look at this purpose, okay? The purpose is to investigate the solid-liquid phase change of lauric acid, an organic compound that is used to make soap, okay? So we're going to look at two different parts. You need to answer the pre-lab questions right here. There are 2 of them, so answer these 2 questions. and then come down to the lab part reading here. Safety precautions. Read the entire lab procedure before beginning the experiment. Work carefully to avoid scalding yourself with hot water. Avoid contact of all chemicals with the eye and skin. Wash hands thoroughly with soap and water before leaving the lab. Wear chemical splash goggles. Wear chemical-resistant gloves and a chemical-resistant apron if you so desire. I mean the gloves and the apron. You definitely need to wear your goggles. Part A is dealing with the cooling curve, so you follow the directions. Part B is dealing with the heating curve. Now, one thing, you can look. You have to take temperature readings here every 30 seconds. You will be making a graph. If you are familiar with Logger Pro, you can make your graph on Logger Pro. Just pick an appropriate temperature experiment that they have in there, and you can make your graphs on the computer. If not, you're going to have to do it by hand, whether you use Excel or whether you use a paper and pencil to make your graphs. So if you're adequate enough with Logger Pro, you can use the computer to make your temperature versus time graphs, but if not, you're going to have to do it by hand. Post-lab questions. Make sure you answer these questions on a separate piece of paper. Let me say that again. Answer these post-lab questions on a separate sheet of paper. Down here, number 7, optional. Number 7 is a bonus question. All right, separate sheet of paper, number 7's bonus. Ladies and gentlemen, chem students, this has been Mr. Braun talking about the pre-lab for It's Just a Phase. Let's investigate.